So here we are looking at a listing of all the comparisons. And one of the questions that comes up very often is, well, I had a knockout experiment. I don't see my gene. How can I confirm that? Or I just like to look at all the genes in my experiment, not within a comparison. So the place to do that is within normalized expression. So first, when immediately entering, you begin with the visual charting experience. So any gene I mouse over and all 21,000 genes from this particular experiment are here, and they're in alphabetical order. I can search for any number of genes, or I can actually select a gene list and filter it down. So if I happen to have a gene list here based on immunology, for example, by selecting that, I will filter down to the genes within that gene list. It's possible to create new gene lists back in the user space with the gene list manager, or also in this location using the bottom bar or within a normal differential expression experience. So gene lists can be very, very handy. And as represented, when I select a gene list, I immediately get an interactive heat map that displays all the results. Or if I go back to all genes here, I can also hold down the command key on the Mac or the control key on the PC, and I'm gonna get a dynamic view right on the fly as I do that. Notice all samples are represented across the bottom here, and each of the genes are represented for each one of these rows as I mouse around. By the way, anytime I want to download this, I can click the download button, and pretty much anywhere within Rosalind, if you want to grab an image, usually clicking on it or clicking on the download button will allow that to be downloaded. So in this particular case, I will now select my I'll select this immunology view that I was working on before. And so now I have 789 genes represented here. There's a couple interesting things that I can do. I can change the color bar across the top, which is currently colored by time course. So we can see that these are my 48-hour and these are my 24-hour samples. But I might want to select by treatment and change that color bar. Another thing I can do is change the reference sample. So let's say that I want to select one of my samples to be my reference example. So I'm going to pick this DMSO from March. And once I do, that zeroes out that particular sample. So the level of expression for every single gene in every other sample is set in relation to its position being up or down from the value within my reference sample. So this gives a really great way to do an ad hoc comparison. In this case, I picked an individual sample, but I could also choose a group. So if I wanted to pick cell line and I wanted to say I wanted to use H358 as my reference, now we can see all the ones with H358, which are colored blue, and Rosalind tries to zero those and say, well, relatively speaking, LU65, we can see the genes that are up and down across those other samples. Or what I might do, for example, is pick time course and choose I want the 4-hour samples. So those are set to 4-hour. And then let's change this color bar back to time course. And we can see from the 4-hour time to the 24-hour time to the 48-hour time, some of the differences that existed for these particular genes across those references. In fact, let's go ahead and take this back to all genes. And by the way, I'll just do a Command A, which is going to grab the first 5,000 genes and dynamically cluster those for me. So here it comes, there it is. So now we're looking at the first 5,000 genes, and I'm using, again, the reference of my samples with 4-hour the time course and comparing that. So this is a great way, again, to do an ad hoc comparison or to do a screening for potential comparisons you want to build or what's happening with different genes. So here I'll pick the, actually let's go to the control. So the control for my DMSO, which is across several cell lines. So that's a little more complicated. I'll pick my hairpin again. And so relative to knocking out the particular gene here that was associated with KRAS, we can see the genes that are up and down regulated. And it looks like I am on a particular signature. So I'll go back to immunology here, select that. And relative to the hairpin, we can see which genes were up upregulated and downregulated, and learn more about that within my normalized expression. If you would like to look at, so a couple different points. One, if there's a gene that you're just not as familiar with, you can go ahead and click the magnifying glass, and that'll link out and display information from NCBI on any gene. So that's, again, a great resource. And also, of course, here I'm looking at the box plots. A great capability, I've got this grouped or colored by time course. I can also do some groupings. Let's say I want to group by cell line. And so now I'm looking at the H358 here, LU65, and A549 here. And as I'm mousing around my immunology genes, I can see the level of expression for every single gene within this nice box plot. I can also group that. Here, let's switch this to treatment. See all the treatments down here and each of their levels. Or I can click this little rotate and see that for each of the treatments across the 3 different cell lines, how things varied. And let's grab some of the nice ones here. I'll take this back up. We can see all of them. And let's go to, for example, fossil. And these are some of the ones that were key for the study of this particular compound. Now, a couple more points. So that was going through all the normalized expression. Well, I did neglect to do one more thing. By clicking on this table up here at the top, I can get a full view of the level of expression across any gene, all the genes in this experiment. And I can just mouse to the right and see all of those. So if you're ever needing the full list of all normalized expression, this is another great place to download that information. It's also available under the file download, but you can access it and sift and sort and look for those here within normalized expression.